Hi everyone, my name is Ana and I am a member of the football team in UFRGS, Brazil. In this video, I'm going to present COPA. COPA is part of the FUTEBOL Control Framework. It's an integrated software which enables the experimenter to monitor each allocated resources and provides the migration of application containers, doing the interplay between cloud and fog. I will use JFED software to allocate virtual machines to COPA. I will allocate and configure 4 VMs in the testbed, 1 to run COPA and another 3 to run the servers with container pools. Once the VMs are loaded, I start the COPA server manually. I create an HTTP tunnel to be able to access the COPA interface in my browser. Light 1 on. Light 1 red. Light 1 green. Light 1 off. The COPA agent is able to collect data from all wireless and optical interfaces and transmit them to the centralized COPA monitor. The convergent monitoring is essential in this experiment to identify the root causes of performance issues and decide if it worths to migrate the processing or not. For example, if the performance degradation of the IoT application is caused by only the wireless link, moving the locus of processing from a cloud to a fog at the network edge will not work around the problem. Otherwise, if the locus of processing is facing processing overload issues in a fog, the migration to a less overloaded cloud can improve the IoT service. The experiment also benefited from the data collected through this monitoring for the development of solutions for automatic dynamic migration. This is COPA interface. In the monitor dashboard, the experimenter can follow the metrics through a real-time monitoring interface, which shows the data of the servers in the experiment's slice. Here we have the monitoring of CPU, memory, containers, and network workload for each server. The monitor has an interface to show the monitoring of each link between the servers, considering jitter and latency as monitoring metrics. This part shows the monitoring from UFMG to Bristol, and here UFMG to UFRGS. In this case, UFMG pool has only 2 optical links. Analyzing UFRGS pool, we can see a real convergent monitoring, considering wireless and optical links, which can also be compared through a summary table. Of the connected wireless devices, can be monitored the quality of received signal as well as the rate of incoming, lost and transmitted packets. Utilizing this information, 3 automatic algorithms were developed to automate the migration of processing based on latency and CPU load. By defining a communication latency threshold or a CPU load limit, the COPA orchestrator automatically moves the container to a less overload server or to a pool with shorted path. In this case, we will use CPU as a parameter. If CPU is above 60%, COPA will necessarily move the processing to improve the service of the experiment. Finally, our goal for year 3 of this experiment is to develop and deploy intelligent algorithms to orchestrate container migrations smartly. This is the current status of experiment of adaptive cloud fog for IoT applications in the FUTEBOL project. Thank you for watching. Goodbye.